This is where the horizontal stabilizer trim control system lives. And what controls the THS? That's right, the famous jack screw. Since we're here, let's take the opportunity and do a deep dive on a horizontal stabilizer trim control on the 737. The 737 is a very basic airplane, and like I always tell you, 1960s technology. But it works, and it works really well. There's no reason to reinvent the wheel. The 737 NG, as well as the MAX, the horizontal stabilizer is being actuated either electrically or mechanically. There is no hydraulics involved in this system. The electrical side has two subsystems. One is it can be controlled by the autopilot. The second one is the control switches on the yoke or the control column. Captain and first officer have it. And just a note, the stabilizer is there to trim the aircraft nose up or nose down. It relieves the load from the pilot from constantly trying to pull or push on the stick. Now the mechanical portion is the wheel itself, that thing that you see spinning. Now, if the electrical portion does fail, pilots are capable of moving the horizontal stabilizer manually by hand, like this. I know somebody's going to ask, and they're going to ask, how come there's two switches on the control column? Well, there's a couple of reasons for this. You see, only one of those switches actually moves the trim, and it's going to be the right switch. Left switch is actually your electrical power. It will prevent you from inadvertently moving that stabilizer, and it will also prevent a short circuit within the system. You have to engage both of those switches at the same time. The left switch will provide the electrical power, making sure that's saying, hey, do you want to move nose up and nose down? And the switch on the right is actually going to move the nose up and nose down trim. Going to activate the trim actuator motor that is attached to the jack screw, which you'll see in a second. It's that big green square looking thing. That's the motor. Here's another piece of information. Let's say you're flying on autopilot and you hit those switches, your autopilot will disconnect. Also, another piece of information, the column cutout switches stop the stabilizer trim actuator when the pilot moves the control column in a direction opposite to the trim direction. The airplane is always trying to protect itself. But the backup features and the redundancies and protections of the aircraft doesn't end there. These are your stab trim cutout switches. This is in case you have a runaway stabilizer. Uncontrolled movement of the stabilizer, either nose up or nose down. Once you hit those switches, it will completely disable it, and now you only have manual reversion. Also, another feature called the stabilizer trim override switch. The override switch is basically there to bypass the column cutout switches if one or both fail. You know, for a 1960s technology airplane, the engineers that designed this were absolute genius. Those are the basics of the electrical portion of the horizontal stabilizer. Now let's talk about the mechanical feature. The 737 is a direct control aircraft. All the inputs that are going to your flight controls are coming from cables. Cables give the input, and then it's hydraulically assisted. Now on the 737 MAX, the spoilers have changed and become fly-by-wire, but that's a whole different topic. Redirect your focus to the trim wheel itself. Internally, the trim wheel has a sprocket. The sprocket is attached to a chain. The chain goes down into the forward E&E compartment. The chain attaches to a lower sprocket, and which turns the forward cable drum. This cable runs from the nose of the airplane all the way to the back of the airplane. The cables are routed through a series of pulleys and go all the way back to another drum, this time in the aft cable drum. The aft cable drum is directly attached to the gearbox that drives the jack screw. As the pilot turns that trim wheel, it will engage all these cables and all these drums and begin to actuate the gearbox and move that jack screw up or down. The gearbox itself does have a few interesting features. It does have a clutch device, and also above the hinge point of the horizontal stabilizer, there are limit switches. The limit switches basically restrict the horizontal stabilizer from excessive motion. There are different limits for manual, autopilot, and flaps up and flaps down. This is in order to not exceed the limitations of the aircraft. Like I said before, airplane is always trying to protect itself. Now you have a good understanding of how this system works. In normal operation, the autopilot will do the job for the pilots and adjust the trim. Autopilot fails or pilot decides to take over manually, they can utilize the column switches. If the column switches fail, they can manually turn the cable via that little wheel inside the flight deck. One thing I did not talk about here, and this is a difference between the NG and the MAX. MAX has introduced a new system which pretty much everybody knows about. We're talking about the MCAS, Maneuvering Characteristic Augmentation System. Now, I'm not going to go deep dive into this right now. Just simply give you the basics. Automatically adjust the horizontal stabilizer. Its sole purpose is to prevent a stall on the aircraft. It will begin to pitch the nose down when the aircraft is approaching high angles of attack at very high speeds. Now I know there's lots of controversy when it comes down to this topic. This is why I'm going to leave this alone, but know that the system exists and that's what it does. Regardless of that, now you know everything about the horizontal stabilizer on the 737 NG and the MAX.